Let's dive back in. This time we are talking about internal consistency. Now, internal consistency can be estimated a couple of different ways. So last time talked about Spearman-Brown a little. So the split half reliability and the Spearman-Brown adjustment can really be inappropriate for a lot of measures. It can be really inappropriate, especially for measures of reliability with heterogeneous tests as well as speeded tests. So heterogeneous tests are tests that measure multiple constructs, because if you just willy-nilly slice it in half, you will have different clusters of constructs, or you'll have kind of built-in testing effects. Now, there are different methods to obtain estimates of internal consistency, including formulas that we'll talk about in a bit by Carter and Richardson, as well as Cronbach. So the basic idea, though, is that if we are using items that measure the same thing, they should elicit similar, if not identical, responses. This is a way to essentially bank on inter-item consistency, which refers to the degree of correlation amongst all the items of a scale. So a measure of inter-item consistency is calculated from a single administration, from a single test form, and an index of that consistency in turn is useful. It's mostly useful to assess if your test is homogeneous rather than it being reliable. So tests are assumed to be homogeneous if they all contain items that measure the same trait, that they're trying to capture a single construct. As an adjective, this is used to describe, like the test, homogeneity is what we're trying to aim for. This comes from the Greek meaning similar, homos. If you're an economist, you hear about this all the time. For those of you who have not had the experience of economics the same way I have, what it means is everything is similar, that they come from the same source. While heterogeneity, which is a big issue with regression when you have heterogeneic effects, I cannot talk, blah, that's when your items are derived from different constructs, and you are artificially smushing them together. I mean, in other words, more I cannot speak. More homogeneity is good if you are trying to measure a scale that has one factor, has one big construct, which is an implicit assumption in most tests, frankly, all tests, because you would expect the responses to be similar if you are measuring the same thing. Now, coefficient alpha is what people refer to either as coefficient alpha or Cronbach's alpha, is a really widely and popular measure for measures of internal consistency. It primarily works for continuous data. So, and here's why this is kind of neat. So, knowing that a composite is the sum of the variance and covariances of a measure, we can actually assess the consistency of that measure by seeing how much of the covariance that exists between items is related to the total variance on the test. Are all the items similar to one another? That's the idea. We will always have a composite sum of the variance and covariances when we make a measure. It's kind of neat. And I literally just said this. So let me repeat it because I have it here. So knowing that a composite is the sum of all the variances and covariances of a measure, so our test score, we can assess consistency by examining how much of the covariance exists between the items relative to the total. This is coefficient alpha. So here we have alpha equals the number of items, k, divided by k minus 1. Let me actually talk about coefficient alpha before I go on this equation ramble, because it's probably good to know about. So here's the idea. So, and we'll talk about some other techniques here, but the coefficient alpha is thought to be the mean of all possible split half correlations. with the built-in correction of the Spearman-Brown formula. That is what is happening here. In contrast, the other method I'm going to hint at for a little bit, the KR20, is only appropriate when we've got dichotomous items. So like yes, no, true, false. While coefficient alpha is appropriate for all non-dichotomous tests. And that formula that I've got here, where K is the number of items, S is the composite variance, and Sij is the covariance between items I and J. So essentially every single combination goes into this and you add them all up and correct for the total number of items in the measure, you get a nice index. And even today, it is, while not the best measure, it is the most popular. Omega's a little better, but it's a little more, it really requires more matrix algebra than I can teach you in this class. So coefficient alpha is, in general, the most popular statistic for obtaining an estimate of internal consistency as reliability. A variation of this formula can be like obtained for the estimate of all possible test retests or split half coefficient. But so you can like tweak this assessment any way you want, or this formula to get some other cool variants. But the idea here is that it's giving you the essentially the average split half. It's really popular, just like split half was popular, because it requires only one administration. Now, I've got a worked example here using the exact same data as last time. And we already know that the sum of the total variance, just adding everything up, is 254. And the sum of the covariances is 152. We can just pop those puppies in for our 3-item test. And we can find out that it has a consistency of almost 0.9. It's pretty nice. So we can also define coefficient alpha in terms of the composite variance as well as the variance for each as 1 minus that. So this can save you some math. So rather than having to like look at every single combination, what we can do is find out what the total variance is, and then find the individual variance for each item and add those up. This is computationally easier than finding the covariance for each item between every single combination of items. For the 3.1, it was a token example, but no test is actually no good test is 3 items. And you may be thinking to yourself, but Nathan, your quizzes are 3 items. Technically, yes. However, they have subcomponents to make it, so in effect, it's more like a 30-item test. Each question is like a testlet. Or that's the idea. So, yeah. But we can restructure coefficient alpha a couple of different ways, which is kind of cool. And it can save us a lot of computation. As we can see here, exact same data, all that jazz, and we get the same calculation. And it's way easier. So I encourage you to take screen caps or actually like work through the slides. Make sure you can do these. And feel free to use the data I generated for each of your individual questions. That should, yeah, on your homework, that should help give you some extra data to work with. If you want more data, I'm happy to give it. I'm happy to send you as many practice problems as you want. Just shoot me a thing. All right. So yeah, let's talk about coefficient alpha a little more. It's considered the lower bound estimate of reliability for continuous items. It's based on this older formula that I already talked about. But here's how you interpret it. So coefficient alpha can range from 0 to 1. Um, and it's a measure of how similar the set of questions are. So here it's a measure of similarity, not of covariation, which is what a correlation is. Um, and so alpha of 0 means there's absolutely no similarity between the items. It's like they're utterly unrelated up to perfectly identical. So essentially, if you had 3 of the same question, you would expect to get the exact same answer for each of them. So it is possible, however, to generate kind of artificial data sets that will yield a negative alpha. Uh, but in theory, this is impossible. And if you do have, for some reason, an alpha that is negative, just report it as 0 because effectively that's what it is. Um, Also, there is a myth that I'd want to talk about a bit, where this idea that bigger alpha is always better. Honestly, it's not. If you have an alpha above 0.9, um, for like a short scale, there might be some redundancy in your items. Again, this is not like a so Striner has got this take. He's got a really great 2003 paper on this. Um, it may be too high, it's not guaranteed too high, but if you have something super high and it's not that way on purpose, then you should really ask yourself, is this an efficient use of measure? Could you make this shorter? Could you make it, are there questions that are tapping the same thing? So if you have individual items that are like super correlated, like 0.99, maybe think about removing one and adding in an item that is a little less correlated because it's okay. Yeah, because it's an index of similarity as opposed to a Pearson correlation, which in theory is both similarity and dissimilarity. Uh, Again, so a correlation of R equals 1 can be thought of as indicating perfect similarity versus a -1 where it's perfectly dissimilar. But in practice, most reliability coefficients range from 0 to 1. You're not really going to see a negative correlation unless you are designing it that way. Um, so in reality, in all likelihood, you will never see one. If you do, please send me an email because that's so cool. Please, like, shoot me an email wherever you are in your life because I'll probably be here. Hopefully, not in this exact same spot. But yeah, so coefficient alpha, Cronbach, it's pretty cool. It's based on a Curter Richardson idea from the late 30s, and it was essentially developed as a reaction to all the existing split half methods. And Carter and Richardson developed their own measure. They made like 25 of these or something like that to estimate. Like they made a ton of them. This one's Formula 20, and it's so named because it's the 20th formula developed in the series. Um, in theory, where when you have highly homogeneous items, your KR20 and split half reliability are going to be similar. However, KR20 is still a better choice for dichotomous items because those items that can be so dichotomous is either like correct, incorrect, yes, no. Even with multiple choice items, if the response can be boiled down to a yes, no, as in like you get points or no points, you can use a KR20. Now, if your test items are more heterogeneous, a KR20 is going to reveal a lower reliability estimate. And I think I've got a table in the course notes, I think, illustrating this effect. But yeah, so here it should look very similar to Cronbach alpha, but instead of working with covariance or total variance or anything in the items, it's this trick you may have learned for calculating variance for Bernoulli trials. hopefully the variance for it's the percent correct versus incorrect for all the total items. Okay, on that note, I'm gonna leave because my pizza is ready.